motion, and this is going to be a conceptual discussion as to what is relative motion. All right. So let's talk about the fact that you could have a coordinate axis, in which the whole measurement is taking place, and there is a body having a velocity v1. Okay, and obviously velocity v1 is a vector, and then you have generally an observer, who is stationary. Okay, and when I say stationary, generally a person standing on earth, and is stationary, is observing this. Maybe this is a car which is going, so this is a car which is moving, and the direction of car as seen by the observer is represented by the vector v1, and has a magnitude also. So both are being observed by the observer. Now this observer, himself, starts moving with a velocity, maybe in some direction. You can assume a simple direction, that this observer starts moving, along the x-axis with a velocity 2, right? So, which means now the observer, also has a velocity. Now, when you have observer also moving, observer is still observing the car. But now, the way observer will look at the car, will change. Earlier, the car was going in this direction when the observer was stationary. But when the observer himself starts moving on the right-hand side, the motion of the car as seen by the observer will change. And the strategy and the method to find how would the observer do, when he looks at the car, how would the car look like? Now, the expression, which means the velocity of car, as a vector with respect to observer, right? This is the way we express this concept. That is how car motion is being observed by the observer, which now has a velocity 2, is written like the velocity of the car when the observer was stationary, and subtract the velocity of the observer when the observer himself is, or herself is moving. So when you subtract these two, what you get is the velocity of the car as seen by the moving observer, right? So this is a moving observer with a velocity v2, and the velocity v2 has been assumed to be constant velocity. Okay, so we are not assuming accelerated motion of any of the bodies. Now, in terms of graphical representation of this motion, you can see that vector v1 is already known to us, and this is where it was. In terms of length, it is maybe O to A, and this actually just represented the direction, as seen by the stationary observer. And a vector v2 is getting subtracted from this vector. Now, when you do subtraction, what you do is you draw the vector v2 in the opposite direction. So if v2 is in this direction, draw v2 in opposite direction. So this is minus v2, and this is minus v2 vector. Just draw it opposite of equal length. And now, since you're interested in finding this expression, you really want to know what is the the relative velocity of car as seen by the moving observer. What you do is you bring this vector, which you have just inverted, the velocity vector of the observer, which is now shown in the reverse direction, and connect it to the velocity vector of the car. And the velocity vector of the car now and the velocity vector of the observer, have been connected with the help of tail and head method, right? So this is a tail of the car, and this is the head of the car's vector, and this also represents the tail of the observer's velocity, but in the inverted direction. So this is your observer velocity, but it is minus v2, right? Now you have two vectors known to you. Now one way is, the angle between them, which is this, and you apply law of parallelogram, because law of parallelogram, is applied when you have two vectors, when they have an angle between them. This is your law of parallelogram, and you draw, a line which is parallel to the vector number first and maybe the vector number 2, and you get a resultant, right? So treat the relative motion, as a resultant of two velocities. One, the velocity of the body under observation, which is car, and the velocity of the observer getting subtracted from the car's velocity. But this subtraction is algebraic, not algebraic. This is, vector addition or subtraction. The negative sign does give an impression of subtraction. So you can use the word subtraction also, or addition. But this is vector addition or, subtraction. So it has a sense of direction included. This is not algebraic, like two numbers getting added. So the point here was, we were trying to understand relative motion. And once you know the resultant of V1 and V2, the direction, it can also come from law of parallelogram. So for example, if we complete the parallelogram here, in our chosen example, we can draw a line which is, parallel to the car's vector, and I'm just showing and trying to make a parallelogram, and and this is a way. So essentially, what you've done is you have converted the problem into a problem of law of parallelogram, where one vector is v1, which is this, and the second vector is this vector. And you can see, by drawing the parallel vectors, what we've done is, this is my parallel vector, and this is my, parallel vector. So you can see the velocity, the resultant, as you can see, will be given by the diagonal of the vector. So once you have the resultant, which is a diagonal of this parallelogram, you would exactly know the direction of the resultants. The direction of the resultant, for example, if this was a parallelogram and your resultant is in this direction, so the motion of the car as seen by the observer, would be the direction of the resultant. So if this represented the velocity of car and this represented the velocity of observer, okay, and this was inverted, I'm just showing a very simple version of it. This is inverted, and this, after inversion is in the right hand side. In our problem, definitely it is on the left hand side, so don't worry about it. The point is, we're trying to, understand the concept of relative motion. So this resultant, which is V car minus V observer, the direction of this resultant vector tells you the direction of the motion of car as seen by the observer, and is called as the line of relative motion. Okay. So we can say when the observer is looking at the car will not go in the previous direction. So when the observer was stationary, the car was moving in this direction. But when the observer has also acquired a velocity v2, the resultant vector of minus v2 and this, which is likely to be this diagonal, for example. So the car will appear to go in this direction, right? So this direction. is called as the line of relative motion. Okay. So if the observer, has its own velocity, subtract the velocity vector from the velocity of the body under observation. Draw the situation graphically by inverting the velocity of the observer, and then use the law of parallelogram or triangle law to show the resultant. And the resultant is the velocity of the car as seen by the moving observer. You can see the car was moving in this direction, but the observer is now seeing that the car is moving in this direction. Okay? And this direction is called as the line of relative motion. So go through this video carefully, and hopefully you will be able to understand the relative motion. Try some numericals. I will solve some numericals, and you can see how this is to be approached as a topic. Very important topic for those who are preparing for JEE and NEET. It's a very, very important question for you. So do prepare for it. And if you like this video, please subscribe to my channel and like this video. Thank you very much.